Hi there. Thank you for clicking on the practice set for quadratic applications. We're going to work through another application problem and work through it with the graph and by hand so you can see how we apply quadratic functions to projectile motion. Please like and subscribe for more math help. Drop a comment or ask a question below and check out some of the other videos that we have on the channel. So pause this video to work these problems on your own and then come back to check your work. First one is a matching problem, and then the others are like find all the things. Okay, so match the point with what it will tell us. So we have our star of the show, the cat. Now that's not on the cat tree. I could have taken a photo on the cat tree, but that's a nice photo, sniffing a basil plant. Maybe she's going to jump off the windowsill. We'll see. All right. So this is matching, like, what might I be asked to find and which point on the graph would that be? And it might help to take a look at this. So here's the cat tree. Okay. So we got the cat tree. We've got our beautiful cat sitting on the cat tree, okay? And she's going to jump off the cat tree. The cat tree should be. All right, stuff that really bothers me. Okay, and she's gonna jump off and hit the floor somewhere. And so the cat's highest point. So the cat's highest point would be right there. That is the vertex, and it would be the y coordinate of the vertex because the height of the cat is on the y-axis there. And so that would be the cat's highest height is the y-coordinate of the vertex. The cat's time to landing, well, that would be cat jumps up, and right here is where the cat hits the ground, and that would be the x-intercept. So there we go. The cat's starting height, okay, right there, and that is the y-intercept. And that means the last one, the time for the cat to reach the highest height. So we got like an x, y, and that would be time and height. So the x coordinate of the vertex. So that kind of grounds us in, okay, now that I see like what point I'm looking for, I can go find it on the graph or engage my algebra skills to calculate what those points might be to answer whatever question I might be asked. Okay, so find by graphing and by hand. So we're going to do this by graphing and by hand. All right, so the cat's highest height. So remember, highest height, we are looking at the vertex, and we have, I didn't label it here, but we have time on the x-axis and height on the y-axis. So this is time, this is height, this is time, this is height, and this is time and height, okay? So at the highest height, that is right there, the highest height would be 9. So 9 feet on the highest height. What is the cat's time to landing? So here goes the cat jumping up, landing. So the time to get the cat to land would be right there. That would be 4 seconds. That's impressive. It's a long time to be in the air. The cat's starting height is right here, okay, when time is equal to 0. So the cat is starting at a height of 8 feet. And the time for the cat to reach its highest height, well, that is another vertex question, and that would be the x coordinate, and that would be 1 second. Okay, now if all you need to do is answer those questions, okay, and maybe your teacher is only assessing, can you interpret the graph, can you connect the points on the graph with what they represent? And I'm aware that the numbers, remember I said the numbers are tweaked in this lesson to make the numbers nice. In a physics class, you'd put together the function yourself and the numbers will not be friendly, okay? But that might be all you need to do. But I have asked you to also do it by hand. So what if you did not have access to a graphing utility where you could just kind of click on the key points and find what they are? So we're going to go through this. Here we go. So the function is right there, and we're going to look for the cat's highest height. Now, I might do these out of order. I did copy the questions. I actually just did a straight copy paste from the first slide, but yeah, I think I'm going to do these two together because they both have to do with the highest height. Okay, so we might as well just like do those together. So the cat's highest height, if you do not have a calculator, we want to do this using what's called the vertex formula. So the vertex formula is x is equal to the opposite of b over 2a, and you might want to substitute that out with a t, okay, just because it's time, okay? And so that would be the opposite of 2, which is -2 over 2 times -1. So that's -2 over -2 or 1. And then h of 1 is -1 squared plus 2 times 1 plus 8. And Desmos will do this for you as well, just so you know. Okay, and what do we have here? That's 1 plus 8 or 9. And if you remember your function notation, what that tells you is when x, or in this case t, is equal to 1, the y value is 9. And so that answers your question. What is the highest height? 9 feet. And what is the time it takes to get there? 1 second. Notice that you actually have to find the time before you find the height. So that has like thrown some of my students at times because they want to start, well, let me find the highest height. And then they get to the other question. They're like, well, I don't know what to do with this. You got to find the time first. So the way this works is you actually have to find the time before you can find the height. And then be mindful about which question that you're being asked, especially if it's a multiple choice question. You might see all of these points as your answer choices. So you really do need to make sure you know which question you're being asked there. All right, and then we'll do these two. So the cat's time to landing. Well, when the cat lands, the height is 0. Okay, that just, I'll give you a moment to process that. Like when the cat hits the floor, the cat is 0 feet high. So that means we need to solve this. Now, this one is factorable, and I'll show you how to factor it, and we'll also work through it with a quadratic formula. I never, ever want to factor with a leading negative, okay? I don't want to do that. So what I'm going to do is multiply both sides of this by a -1. Okay, -1 times 0 is 0, and then we're going to distribute that negative through. So that's going to give us t squared minus 2t minus 8, and then that we can factor. Okay, so we've got t squared and -8. We do 1 times -8, which gives us -8. And then we factor that, we get 1 times 8, cannot get a 2 from that. 2 times 4, yep. It's got to be a -2, so I want +2 and a -4. So this will be 2t and -4t. GCF between 2t and t squared is t. T times t is t squared. T times 2 is 2t, and -4 times t is -4t, and -4 times 2 is -8. So I get x plus, or x, that's just habit, t plus 2 and t minus 4. That means that one of these, I don't know why I did that. Oops. Yeah. I don't know how it's showing on the video, but in my computer, it has gotten really laggy. Okay. Subtracting 2 from both sides, so we get -2 is equal to t. That doesn't make any sense in the context of this problem. Okay, it does not make, like, what is negative time? But here we go with the +4. Okay, and so t is equal to 4 seconds, and that is the answer that we knew from the graph. Now you could also do this by using the quadratic formula. Okay, and if you were using the quadratic formula, you would have a is equal to -1, b is equal to 2, and c is equal to 8. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of 2 is -2 plus or minus the square root of 2 squared minus 4 times -1 times 8 all over 2 times -1. So we have -2 plus or minus. What is that mess? That is 4 plus 32 all over -2. 4 plus 32 is 36 all over -2. The square root of 36 is 6. And now we finally got it to where we can split it up. So we would have -2 plus 6 over -2. So that is 4 over -2. There's the -2. Or we have x, and I'm using an x there instead of a t. That's okay for you guys. -2 minus 6 over -2, which is -8 over -2, which is the 4. And you can really see there why we prefer factoring. Factoring was just a lot less messy, but it does involve like remembering how to factor. If you're wondering, like, why was I allowed to do this? Like, I'm actually factoring a different one. Essentially what we're doing is we're flipping the parabola over, but we're not changing the x-intercepts. And I do have a quick video on my channel. It's one of the shorts, so you can go into the shorts and kind of scroll through. It would also probably be in the quadratics playlist. Not sure I moved my shorts over to the quadratic playlist though. So you can check that out, like why that doesn't change the answers. Okay, and last but not least, is this last one. What is the cat's starting height? Well, when the cat is at the starting height, that is when t is equal to 0. Okay, that's the beginning. And so what we would do for that is simply plug in the 0. And 0 is the best number ever. So -0 squared plus 2 times 0, that's all 0, leaving us with just the 8. And so the starting height would be 8 feet. The biggest like pain in the neck one to do is the landing, okay, because that does involve solving the quadratic equation. Now, if a teacher writes the problem so that it is factorable, you should be able to factor it. In a physics class, you're probably gonna have decimals all over the place, so you would use the quadratic formula. There are ways to get Desmos to do the quadratic formula for you, and I have some videos on my channel about that as well. So be sure to check those out, where you can like dump the whole quadratic formula into Desmos and then use the sliders to get it to evaluate it for you. Okay, last question is asking you to find the height at a particular time. So how high is this cat at 3 seconds? So we're going to plug in the time of 3 seconds and essentially evaluate that. And again, you can use Desmos or a calculator to do this. -3 times 3 is -9. 2 times 3 is 6. And I'll go ahead and add from left to right. So this would be -3 plus 8, which is 5. So at 3 seconds, the cat is 5 feet off the floor. So you'd have this point would be on the parabola. So there's the time and there's the height that goes with it. There you go. Now, what I hope this does for you is that it helps you see the applications, connect the key points to the graph, and just really deepen your understanding of how that function notation works, the idea of the input of a time and an output of the height, and how the ordered pairs represent the motion of, in this case, our cat, as the cat is soaring through the air. Please like and subscribe for more math help. Drop a comment or ask a question below to engage. So if you've got some things that questions, or maybe you've got a different problem that your teacher has recommended you do and just want to know how it connects to this, please ask a question and check out the many other videos and practice sets we have on the channel. We have multiple choice playlists for strategies with that, and tons of Desmos strategies for working with Desmos to help that with our math content. So please check those out, and I hope to see you in a future math lesson.